So let's do an example of a solid. Here's the equations that define the solid that I want to look at, and then I want to come up with both pictures and formulas for the three different projections associated to the three types. So we won't set up any actual integrals, but we'll practice visualizing everything, and hopefully it'll make things a little bit clearer for you. So let's begin by drawing our solid. So this paraboloid, is going to open along the y-axis, and it's going to look something like this. And then, let's make that one better. And then out here at y equals 4, we're going to slice it off. And so we get something that looks like that. This is happening at y equals 4. Okay, so that's the solid. Now, for each of the types, we're going to project this thing into the xy plane. Let's actually label x, y, z. Sorry, that would be a lot better. Although that's my standard orientation, so shouldn't throw you off too bad. For each of these, we're going to project this thing into the xy plane, the yz plane, and the xz plane. Let's just quickly do the projections visually. So if you were going to project this thing onto the xz plane, you can see that you're going to get a circle, right? When you collapse this circle down, you're going to get that circle. When you project this thing onto the xy plane, you can see that I'm going to get a parabola, all right? That's somehow easy enough to see. And then similarly, when you project this thing onto the yz plane, you're also going to get a parabola. So visualizing the projections here in 3 space isn't too bad in this example, but let's actually practice writing them down. So let me make a grid, and let's begin thinking about, we'll just go in order. So we'll think about type 1. So type 1. So type 1, I'm going to stand up here, and I'm going to look down. And what am I going to see? Well, I'm going to see a parabola, and I claim that in this particular case, the parabola that you're going to see is just y equals x squared. But it's not enough. Please catch this. It's not enough to simply say, oh, look, I'm projecting into the xz plane. That means z is 0. I'm just going to plug in z equals 0, and I get y equals x squared. In this case, that works, but it doesn't always work. What's really happening is the widest bulge of this paraboloid is happening when z is 0, right? And so in that case, you can see that, okay, the widest part that I'm going to see is happening when z is 0, and so I quite literally get this y equals x squared, and then of course we're stopping it at y equals 4, and so that's the projection that you would use for type 1. All right, let's clean this up a little bit, and let's work on a type 2 now. I'll switch colors just to help keep it clear. So type 2, we're going to first cut type 2 along the x-axis, but that's not what we're interested in. We're interested in projecting it. So I would cut it along the x-axis, but then I want to project it into the yz plane. All right, so again, looking at it in the yz plane, I can see that the widest thing I'm going to see is actually right here when x is 0. And so when x is 0, I get y equals z squared. I'm going to think about the y and z, and so my equation is y equals z squared. That's a sideways parabola that looks like this, and of course we're going to whack it off here when y is equal to 4, and so I get that region. That's the projection that I get when I do type 2, and I'm looking this way. This one was type 1. Now I'm standing here. I'm looking this way, and I get type 2. And then finally, I want to do type 3 with you. So for type 3, we're going to project this into the xz plane. So type 3, we're going to be standing over here looking that way. And here's the key. If you were to just say, oh gosh, well, I'm projecting into the xz plane, I'll just plug in y equals 0. That would actually give you the wrong equation. When you plug in y equals 0, you would get 0 equals x squared plus z squared, and that's not what we want. So it turns out that you actually want, the thing you're going to see is this disk. This disk hides all the rest. Do you see that? When you're standing here, this disk hides the rest of it. And this disk is defined by x squared plus z squared equals 4. So that's the equation that we want to actually capture. This was type 2. This is type 3. And we're going to draw x squared plus z squared equals 4. And that's, x squared plus z squared. That's what we get from that view. So what we've drawn here are the associated projections for each of the types. And you would use these projections to set up double integrals. So quite literally, you'll be setting up the first integral in your triple is going to come from a cut in the solid, and then the other two integrals are going to come from cuts in the projection. And so we'll need to be able to do that. Okay, I'll stop this video here just to keep these from being too long, and we'll keep